Good evening, everyone. Okay, so the last time we discussed what is EMF, what is internal resistance, and what is terminal voltage, and finally we got a relation, we derived a relation between those three, right? That V is equal to epsilon minus IR. We are now going to solve some questions related to that. Okay, so we're going to solve the question number example 3.5. We will now solve the example 3.5. Yeah, I know screen is not visible. I've not started it yet. I'll just start it now, right? So example 3.5. Everyone please open it. Okay. So it's a big example, right? It has 3 parts, right? Okay, so let's start. Now, right now, let's just focus on A. Okay, we'll worry about B and C later. First, let's complete A. So it says there is a network of resistors, right? Network means collection or combination, right? There's a network of resistors, right? And it is connected to a 16-volt battery with an internal resistance of 1 ohm. So what is shown here in this circuit is that there's a 16-volt battery, right? There is a 16-volt battery, right? And and this 1 ohm is used for indicating its internal resistance, right? So we can draw it like this also, right? And sometimes some books and some authors draw it in this way as well, right? So this is indicating that this whole thing is one battery or one cell, right? And its EMF is 16 volt and its internal resistance is 1 ohm. Okay, so drawing like this or like this would mean the same thing, all right? Because here it is written in the question that internal resistance is 1 ohm, all right? So I hope that is clear, right? So actually only 5 resistors are connected, right? Only 5 resistors are connected. I hope that is clear. 1, 2, 3, 4, and 5, right? Only 5 resistors are connected. Okay, now let's let's start solving this. Okay, so first of all, what we have to do is we have to calculate equivalent resistance of the network. Network means, see this part, okay, of these 5, right? We don't have to consider the internal resistance in the network. Okay, so calculate the equivalent resistance. Hurry up, come on. So now you see this is a slightly complicated case. This is a slightly complicated case because if you talk about 1 and 2, what are 1 and 2 in? Come on, what can you say about 1 and 2? 1 and 2 are in? 1 and 2 are in what? Very good. 1 and 2 are in parallel, right? So their equivalent resistance, will be 4 and 4 ohm in parallel. How much will that be? 2 ohm. Well done, people. 2 ohm, 2 ohm. All right. Yes. So we have 2 ohm here, 1 ohm here. And now what about 4 and 5? What about 4 and 5? What about 4 and 5? Yes, they are in parallel. Very good. And their equivalent will be? Their equivalent will be? Yes, very good. 4, 4 ohm, 4 ohm. All right. Now you could see, you could use it for 2 resistors in parallel. I think, oh, sorry, 2 resistors in parallel, right? You may have learned this in 10th also, that if you take the LCM of that 1 by R1, 1 by R2 formula, you get this, right? So for 2 resistors in parallel, you can use this as a very easy way, right? Okay, I hope that makes sense. So that's what we have, right? So this is the network, correct? So the equivalent resistance is clearly, I'm not even going to worry about that, it's clearly 7 ohm, all right? Okay, so that's it about equivalent resistance of network. So part A is solved. Okay, part A is solved. Yes. Okay, what happened, Aman? Now let's go to the next question. B, obtain current in each resistor. So now, yes, Aman, it will be good if you can draw a diagram right after every step. Okay, right? પેનથી જ કરવાનો હોય, પેન્સિલ વેન્સિલ નહીં લેવાની. સર્કિટ ડ્રો કરવા માટે કોઈ પેન્સિલ યુઝ ન કરે. Okay, now we have to find current through each resistor. Avinash, that is terribly wrong. બધામાં same no આવે. So first of all, we have to find, listen to this very carefully. First of all, we can find what's the total current. Total current means the one flowing here. I hope all of you do realize that when this current I will come here, right? If I'll just draw that part again. This is the current I coming in here. Over here there is 1 4 ohm resistor. Over here there is 1 4 ohm resistor, correct? So I hope you realize that this current will split or divide, agreed, into two equal parts, right? Both these parts are equal here because both are 4 ohm, right? For both 4 ohms. Clear? If you use equivalent resistance of all, you'll get the total current. Everyone, please be careful. You have to try and follow the current's path. It will flow like this, and now it will split. આપણે આનો current find કરવાનો છે, આનો નહીં. First of all, is that okay? The question is not find I. Question is find what's the current here, what's the current here, what's the current here, and here and here. Right? So I hope it is absolutely clear what we have to find. So, like I said, first of all, we can find this I, and then we can find I by 2 and I by 2. Okay, that's not a big deal. So to find I, you could just write current through battery. Okay, I is equal to, clearly it will be epsilon upon 7 plus 1. Now this is very crucial, everyone. No, I don't understand, Kodal, what you're trying to do. I think you're making it unnecessarily complicated. Everyone, listen to this. What have I done here? I've written epsilon upon 7 plus 1. Why so? Well, I want all of you to look at the whole thing. This is what we have, right? Please, everyone, don't try to jump the concept. This is what we are given, right? We are given that there is a battery. એટલે જ કહું છું, તમે મારાથી આગળ થવા ન જાઓ ને ખોટા. Listen to what I'm saying, right? Everyone. Okay. So as far as the answer of A is concerned, mind well, the answer is 7, right? As far as A is concerned, the answer is 7. There is no doubt about that, because the word says resistance of network. Network એટલે કોનું network? આ બધાનું network. બરાબર ને? This 1 ohm is not a part of network. 1 ohm is inside the battery. So it's not a part of network, first of all. Now, if you come to this picture, everything will be very clear, right? Come to this picture. Look at that drawing. Drawing હું આમ તો draw નથી કરતો, એ તમને ખબર છે. જેટલા વધુ drawing એટલું વધારે સમજાશે તમને, right? So now if you look at this diagram, so do you realize that effectively, ultimately, the resistance is 8 ohm and not 7 ohm? Clear? Is this clear, everybody? Effectively, the resistance through which this current will flow is 8 ohm. Why 8 ohm? You can say that this 7 ohm and 1 ohm are in series. You can say that 7 ohm and 1 ohm are in series, right? Okay. Yes, 1 ohm for the battery. So 7 up and 1 down, that's absolutely wrong. What is meaning of 7 up and 1 down? Okay, you mean to say 7 over here and 1 over here. Oh, all right, fine. Okay. Just a minute. Looks like by a mistake we have shifted or scrolled to 11th standard. Just give me a moment. Okay. Right, in figure. And yes, so you know, if you, for those who love formula, this is the formula of current. For those who love formula, this is the formula of current, right? I hope that makes sense, right? Because it's actually like that. Now this 16-volt battery, this 16-volt battery has to give current through 8 ohm. Clear? Right? I hope that is clear, everyone. Right? 16-volt battery has to give or pass current through 8 ohm. Right? Okay, see, we have done it in an intuitive way. If you want a proof of this formula, you can contact me personally, right? I will help you out about deriving, but I don't really think it's necessary. It's very intuitive, right? I think most of you would have understood how we get this, right? So if you want, you can write it down. I'm just waiting over here for a moment. If you want, you can write it down and then we'll continue with the sub. Okay. Right. Now, so I was saying that current through the battery will be I, which is equal to epsilon, means 16 divided by 8. Clear? So that's going to be 2 ampere. Right? Is this clear, everyone? Is this clear? Yes or no? Right? No confusion whatsoever? Okay. Okay. All right. Looks like almost everyone has got it. So fine. So this is the current through battery. Now, again, have a look at that diagram. Current comes in like this and then goes in this resistor and goes in this resistor, right? So here, if it's I, which is 2 ampere, then of course here it's I by 2, which is 1 ampere, right? Okay, right? So you could just put current through each 4 ohm resistor is I by 2, that is equal to 1 ampere. Just write it in bracket, equally divided. That's it. Okay, એટલું reason આવડી ગયું હવે. બરાબર ને? Equally divided, right? Okay. Now let's go to the next resistor. Who's next? Okay, this 1 ohm is next, this one, right? So for that, I think it's quite clear that whatever current flows here will also flow here, right? Because here it splits and then it comes back. I repeat, here the current splits and then comes back, right? Gets added. So you could just write current through 1 ohm. Okay, what is the current through 1 ohm? Is going to be 2 ampere, right? No doubt about that, right? Easy, right? This one is very easy. Okay, so now what to do when the two resistors in parallel are different? That is, I am talking about 2 ohm and 6 ohm. Okay, so for that, it's, I think, easier if we call this R4 and R5, right? Okay, so these two currents we are going to call I4 and I5. Okay, I need to actually draw a bigger diagram. I really hate when the diagram is very small. So I'm saying that if this is R4, which is 12 ohm, I think, right? So let's say this current is I4. And over here, let's say this R5, which is 6 ohm, right? Then the current here is I5. Okay. So now how to handle this situation, right? The question is how to handle this kind of situation. See, for this, right? For this, if you would just look one step back in the diagram here, this diagram. See, this is why I was insisting that we draw a diagram, right? This is why I insisted that we draw a diagram here. So of course the current is I over here. It will pass through this 4 ohm, right? Okay, right? If you want, you can call this figure 1, right? So then you could say as R4 and R5 in parallel make 4 ohm. Okay, 4 into I should be equal to V4, which will be equal to 12 into I4. Okay, I hope this is clear. Can someone tell me the reason for this? Can you tell me the reason for this step? What reason, what logic do we have here? I'm waiting for you, everyone. Can you tell me the reason for this? So, we don't have a lot of people giving me reason. I've only got 3 answers so far. Okay. The, the reason is, listen to this carefully. In parallel, what is same? In parallel, what is same? Voltage should be same, right? Okay, we did such things in capacitors also, right? So what I am saying is that the voltage for this resistor, right, and the voltage for this resistor and the voltage for this resistor, all the 3 are same, right? So effectively I can also write it like this. Is this clear? Yes or no? Now again, it is that in parallel the voltage should be same. So the voltage for R4, the voltage for R5, and also the voltage for this should be same. Method absolutely clear? All right. Okay. So now if we use that here, we already know what's the value of I, right? So we can find I4 easily. I4 is going to be I by 3, which is going to be 2 by 3 ampere. Okay. Okay, and I5 is going to be I 2I by 3, which is going to be 4 by 3 ampere, right? Along with this, the advantage of this method is that we can also find V4 and V5 easily, right? That is part C of the question, isn't it? Right? We have already found V4 and V5, right? Okay. Okay, so let's continue with the third question. C part, C, right? So if we talk about C, the C part says obtain voltage drop AB, that is VAB, means potential difference between A and B. Then we have to find potential difference between B and C, and we have to find potential difference between C and D. So we have already found potential difference between C and D, right? I hope all of you realize that this is potential difference between C and D because the two resistors were connected such that this is C and this is D, right? Okay, so that's done. Now let's look at potential difference AB, right? So I think you agree, I think that you agree it is either V1 or V2, whichever you want to call it, right? It is either V1 or V2, correct? So what is this? What is this equal to, everyone? Hurry up, come on, find it quickly. There are 2 ways to find it, right? There multiple ways to find it. Do it fast. Come on, people, I want all of you to take part. Either get the answer or ask that how we get it. Okay, come on, hurry up, hurry up, hurry up. Unit Kotu, Khushi, Rutwa, please write the unit. Yes, Srishti, well done. Yeah, that's right. Shivangi, correct. Kia, it's right. Yes, Rushabh, unit. Devanshi, it's right. Yes, Sakshi, well done. Dhawal, correct, very good. Yes, Rutwa, that right. Madhav, correct. Very good. I've got all answers correct. Well done, people. Well done, well done. All right. Okay, Purvendra, your answer is right. Avinash, yours also right. Okay, very good, everyone. So 4 volt. Okay, so that's done. Right? Yes, Hardev. No, Arshad, why should it be 16 volt? See, you could write V1 as current through first resistor into its resistance, that is 4 ohm, correct? And I1 is 1 ampere, correct? I1, current through first resistor, right? So 1 into 4 is 4, okay? All right, so now the last one remaining, VBC, right? Then I'm leaving for you, okay? I will not even bother, right? I think all of you would have understood how to do it, right? Okay. So based on this, I want to give you a homework question. I know you have test, but that's only a very minor test. You don't have to worry about it. Kal thai jau joy. And I want all of you to send me your solutions. Okay, you have my number. Don't worry, you can send the solutions, right? Everyone. Only those students who send a solution, those their questions or their doubts will be answered. All right. So here is that question. Okay, so this is your question. All right. Please click a screenshot, everyone, so that you can solve it. Please either click a screenshot or draw it and write it very fast. Okay, I'm just giving you 30 seconds now. અત્યારે સોલ્વ નથી કરવાનું, સોલ્વ પછી ગમે ત્યારે કરજો, but send me the solution before tomorrow's lecture. All right. Okay, fine. I think that is it, right? Now let's go to the next. So now I'm going to ask you to solve following questions as homework. Okay, so these questions are homework. Exercise questions 3.1, 3.2, 3.18, C and D. Okay, so all this is homework, everyone. All this is homework. Okay. Now I'm going to example કયો example અવિનાશ? No, sending exercise is up to you. If you get stuck and if you want help, then you can send it to me, otherwise it's fine, right? Okay, so now we are going to solve one. I mean, I'm going to explain this concept by giving an example, right? Yesterday, if you remember, we talked about charging of battery, correct? So now let's practice that. Okay, right? So for example, here we have, let's say, a 10-volt battery, right? But it has internal resistance 2 ohm. Okay, right? Let's say here we have a 10-volt battery but with internal resistance of 2 ohm, right?